everyone. In this video, we will be evaluating functions, and this is the second part. Let's take this example right here. Suppose we are given f of x is 5x minus 7 and g of x is negative 2x plus 4. We're supposed to evaluate these expressions that we have here. So we have f plus g of negative 3. Now notice that this f plus g can also be rewritten as okay, so it can be rewritten as f of negative 3 plus g of negative 3. So then we can go ahead and plug this expressions that we have right here. So we have our f of x was actually 5x minus 7. So I'm just going to go ahead and write this up here. Okay, so what I did was I wrote the f of x, which is this expression that we have right here, 5x minus 7, plus we have g of x is negative 2x plus 4. Now, what we're going to do next is we are going to plug this negative 3 to each of the x's. So this would come out. Okay, so I plugged in the negative 3 to all of the x's in the expression that I've set up over here. So this would come out 5 times negative 3 is negative 15. And then that's minus 7 plus negative 2 times negative 3 is a positive 6 plus 4. So then we are able to get negative 22 plus 10. And that would give us negative 12. So the value for f plus g of negative 3 given the f of x and then the g of x up there is negative 12. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this f minus g of 6 can also be rewritten as the other option of solving this is to determine what the f of 6 and then the g of 6. So then we are given the f of x there and then the g of x so that we can go ahead and show the work on the bottom right here. So I'm going to start with the f of 6 first. So this is f of 6 is actually equal to, I'm going to write this equation up here. So that is 5x minus 7. So we plug in the 6. So this would come out 5 parentheses minus 7. So this would be 6 over here because that's f of 6. So this comes out 30 minus 7, which is 23. And so we can go ahead and show the work for the g of 6 too. So I'm going to show the work on the side right here. Okay, so our f of 6 is 23 and our g of 6 is negative 8. So that we can go ahead and plug this in here. So our f of 6 is 23. So I write that over here, 23. That is minus. And then our g of 6 is negative 8. So then this would come out 23 minus negative 8 is positive 31. So this is the value of f minus g of 6 given the f of x and the g of x up there. So this is 31 right here. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example right here. So we are given the f of x again and then the g of x, and we are supposed to determine the f minus g of negative 2. So this f minus g of negative 2 can also be rewritten as okay, so then we plug in the f of x. So the f of x is gonna be 2x squared plus x minus 1, and then the g of x is 3x minus 5. So I'm just gonna write that over here. Okay, now we are going to plug this negative 2 into each of the x's here. Okay, so when I did the math, it came out to be 5 minus negative 11. So since these two are two negatives, these two will come out positive. So that comes out 5 plus 11 is 16. So our f minus g of negative 2 is 16 right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, this g minus f of negative 2, because others are going to think like this 2 would come out the same because they're just the same values that are put in there. We have a negative 2. So it gives us, it's going to give us the same answer. So their answers will not be the same because you see the f minus g and then the other one is g minus f. So they must not be the same. So let's show the work down here. Okay, so we can actually show the work by determining the g of negative 2 and the f of negative 2 separately. So I'm going to show the work on the bottom right here. So this is the other way to do it. So I will, let's solve for the g of negative 2 first. And we also have to show the work for the f of negative 2 on the side here before we plug these values in there. Okay, so the value of f of negative 2 is 5, and then the value of g of negative 2 is negative 11. Again, this is the other way to do it, where we determine the values of g of negative 2 first, and when we subtract the value of f of negative 2, or you can do it this way, where you put them all together. So this would come out, our g of negative 2 is negative 11, and then that is a minus. So that's the g of negative 2. So I got that over here. And then we minus, that's the operation, that f of negative 2 is 5. So I put in there. So we have negative 11 minus 5 is negative 16. So the value for g minus f of negative 2 is negative 16. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So we are given, again, the g of x and then the f of x, and we're supposed to determine the value of f times g of 4. So this can be rewritten as the product of f of 4 and then the g of 4. So we can go ahead and rewrite this as... Okay, so we are going to multiply these two functions that we have right here. So we start with f of x. So that would be... Okay, so what I did was I plugged this 4 into all of the x's, and then it came out to be 35 times 7, and that is 245. So the f times g of 4 is 245. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this f divided by g of 3 is actually equal to f of 3 divided by g of 3. So then we can go ahead and plug the expressions in. So our f of x is 2x squared plus x minus 1. And then the g of x is 3x minus 5. So I'm just going to write that up here. Okay, so then we are going to plug the 3 into all of the x's, and this will come out. Okay, so the value of f over g of 3 is 5. So after we did all the math here, it came out to be 5. Did you get the same answer as this? Good, perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!